Welcome today to our third Weddell Sea Expedition video conference. My name is Lizzie Rosenberger and I am with Reach the World and the program manager here for the Weddell Sea Expedition. We are working with the Weddell Sea Expedition in partnership with the Explorers Club, and I have a member of the Explorers Club here who I'm going to unmute really quickly so you can all see, Julie Chase.
Hello everybody. Welcome to the Explorers Club. We're all working together and collaborating on this fantastic connection to the Antarctic Weddell Sea Expedition.
Thank you, Julie. So Julie might be popping in from time to time to answer a question or two as well. We also have from Reach the World, we have my coworker, Tim, who will be manning our chat. So here's Tim to say hello.
Hey everybody, I've opened up the chat on the side of the screen, so if you have questions for Holly and her friends in Antarctica, make sure that you submit them there.
Excellent, thank you, Tim. And we have about 15 classes online today, which is excellent. So what we'll do for today, our theme is our first science theme. We are very excited. Holly has two wonderful guests from the expedition that are joining us here. And so I'll show you Holly and her two guests. We can have them introduce themselves, and then we want to give each of you classrooms an opportunity to say hello and give them a wave. So once Holly's introduced her guests, I'll unmute each classroom one at a time to say hello to them, and then we can get started with Holly sharing what's happening in Antarctica.
Hello everyone! Hi from Antarctica, hi from the Weddell Sea. I'm really excited to be saying hello to you guys from one of the most remote places on our globe. For those of you who've been with us before, hello again. For those of you who it's your first time, hello and welcome. I'm joined today by two really amazing guests, two scientists. On my right, I have Sasha Montelli from the University of Cambridge.
Hi, nice to see you.
He's also from Russia. And then on my left, I have Bettina Frinault, who is from the University of Oxford. And it's also originally from Manchester in the United Kingdom. Yeah. So well, maybe if you guys want to come and say hello, and we can tune you all in before we get started, just so we can see who's with us today.
Excellent. So we're going to do questions in just a minute, but I'm going to say your teacher's name, and then when you hear the name of your teacher, you can all give a really big wave and hello to our guests today. So we will start up here with Mr. Whitney's class. Go right ahead.
We're gonna do that. Hello again, Mr. Whitney's class.
All right, we have Miss Kutzman's class.
Hello.
We've got, next is Miss Long's class.
Hello, Miss Long's class.
Hi.
Excellent. Next we have Miss Ives' class.
Hello again. Hello, Miss Ives' class again. Yeah, they've been on before.
They have. Next we have Miss Davison.
Hello.
Up next we've got Miss Paz. I hope I said that right. Excellent. So next we'll have Miss Palmer's class.
Hello again, Miss Palmer's class.
Hi. There we go. Excellent. And then next we have the Miss Rogers class. Mr. Rogers' class.
Hello, Miss Rogers' class.
Excellent.
Hello from Antarctica.
Next up, we have Miss Latour's class. Wonderful, so excited. We have a couple of classes that don't have their videos on, but you can still, hopefully we'll unmute you and then we will see you as well. So we have Mr. Gorin's class.
Not one, that's embarrassing. Sit down.
Oh, hold on. I think we lost Mr. Gorin's class, so hopefully they can rejoin us. Oh, there you are.
There they are. Big.
I think there might be quite a few classes in there together. And then we have Miss Stevens' class. Do we hear anything from Miss Stevens' class? We'll ask them to start their audio. We can come back to them. And then Mr. Nelson's class. Mr. Nelson, are you there?
Yes, I'm here in Montana.
Excellent, welcome.
Hello.
Thank you.
Hey. It's Montana.
And I think that, oh, Miss Stevens' class has video. Let's see if we can hear from them. We see someone in Miss Stevens' class. They're coming in to view. So they are, let's see. They are waving, excellent. We'll work on their audio in just a little bit. So we do also have a few classes that might be joining us along the way. So just a reminder for teachers and students, we're gonna have Holly and the scientists be the only microphone talking for a little bit so we can hear them nice and clearly. And if you have questions, please use the chat if you think you're gonna forget them. If you don't think you're gonna forget them, hold on to them in your brain, and then when we have our questions and answers, we'll go through a class at a time and you'll each have a chance to ask one, hopefully 2 or 3 questions, depending on timing. So, without further ado, Holly, I will mute myself and it is back to you.
Great, awesome. Thank you so much, Lizzie, and welcome everyone. I can see a few familiar faces, a few familiar classes that have definitely tuned in before. Today we're going to be taking you through some of the science program that we've been up to in the last week or so. And I have, like I said, 2 amazing guests with me today who've prepared short presentations for you all. So I thought that we would start today's call, if I screen share with you guys. Let me just get onto my screen share. A presentation that we have prepared for you all. Can you just give me a wave if you can see the presentation so that I know that you can all see it? Can you all see my screen share? Lizzie, can you see the screen share?
Yes, we can see it.
Brilliant. Okay, so I thought I'd start with showing you some of the photographs that we've taken this week in the Weddell Sea. So you can see here, we've got the window the view from outside my cabin, my bedroom. And then here you can see a group of the scientists collecting a sample of ice. This is a very, very large sample that had to be crane lifted onto the front deck of the ship. And then we can see one of our friends in the blue helmet here, that's Christoph. And if you've been following my blog, you'll see a photo of Christoph who went into the kitchen with me. The next photo that we have, this is a photograph of how we travel from the ship onto the ice floe. So as you can see, we've all got safety jackets on. You hold on to this net here and you get crane lifted from the ship onto the ice floe. Now, when we went onto this ice floe, we had been on the ship at this point for about 3 weeks. So everybody was very, very excited to go and stretch their legs, as you can see in this photograph. So here's a photo of me and my friend Pierre from France, who works as a data surveyor. And a data surveyor is somebody who gathers the information that's from the AUVs, the autonomous underwater vehicles that we have on board the expedition. And he scans through the data, preparing it to give to the scientists, so to people like Bettina and to Sasha, but he also looks on the seabed for any anomalies that might be a shipwreck, because as some of you know, most of you will know, that we are also here looking for Shackleton's lost endurance ship. Got stuck in the ice in 1915. So this is us when we got onto the ice floe and stretched our legs for the first time in 3 weeks. Here's another photograph of me playing a little bit on the ice floe. You can see that I hear him sliding down a mound of snow with the beautiful Agulhas 2 in the background. For those of you who tuned in on our last Reach the World session, I was with Jermaine and Sibon Guillet, and we did a session about life on board the Agulhas 2. And if you did miss it, you can get it on YouTube because it has been shared. And there's some really interesting facts about the food that we eat, what we do with our waste, what we do to keep clean. It's a very interesting blog about life on board Agulhas 2. And then here I just thought there was a really cool photo that we took. Sasha actually took this photo. And this was taken over the port side of the ship. And here you can see underneath the ice floe. So actually, the ice underneath the water is a lot bigger than what you see on the surface. 5 times bigger.
Yeah, about.
And it's about 5 times bigger under the water than what we see on the surface. And you can see just how clean and how clear the water is in Antarctica, because you can see underneath the ice floe here. And then I thought I'd just show you some pictures of the Adelie penguins that we've seen this week. In my blog, there's been a few posts about the Weddell seals, the leopard seals, the minke whales, the emperor penguins, and these are Adelie penguins. And these were taken when we were on the ice floe at the beginning of the expedition. So, without further ado, I'm going to introduce you to Sasha Montelli from the Scott Polar Research Institute at the University of Cambridge. And this is Sasha doing a little bit of science on the ice floe. So, over to Sasha.
Hello, everybody. Nice to see you all. So many of you. Is my presentation on there
Yes.
as well? Yeah. So my name is Sasha. I'm originally from St. Petersburg, from Russia. Did my undergraduate degree there, followed by a degree, master's degree in University of Texas in Austin. And then this is my 4th year now of my PhD at the University of Cambridge Scott Polar Research Institute. And I study history of ice sheets in the past. So if you look at the map of our planet from the top and from the bottom, you can see that Arctic, which is to the north, and Antarctica, which is to the south, are covered. Large parts of this area are covered by ice. And so Arctic or north, or the center of the Arctic region, if you can say so, the North Pole, if you school somewhere in Kansas, then if you drive about 3,000 miles to the north, directly to the north, you'll reach the center of this area. And if you drive about 8,000 miles to the south, you'll reach Antarctica, or the South Pole, rather. And so I use different methods to study the history and the fluctuations of this past large masses of ice. Ice sheets, large masses of ice, both in Arctic and Antarctica, if you sum them up, you can see that they actually lose in mass at quite fast rates. And this is an example of Greenland, of huge meltwater that is on the surface of the Greenland ice sheet, which then drains into the ocean and increases the sea level. Another mechanism of ice sheet mass loss is through calving. This is the time lapse taken from the space, actually. So you can see that through week by week, the ice sheets are drained by this large glaciers. And these glaciers calve when they reach the sea. They calve big icebergs. Sometimes these icebergs actually can reach really huge dimensions. For example, this is one of the largest icebergs ever recorded, 4 times the area approximately of Los Angeles. And this is in the left top corner is myself standing next to this iceberg as we approached it about 2 weeks ago. And so my research focuses on the record from the seafloor, record of this past ice sheet events like calving and ice sheet advances and retreats. And using this, we can help better place the former and the more recent changes of large ice masses in the wider historical context. And this is just a final slide with the example of some of the ice fieldwork that we've done recently using radars mounted on drones to measure the thickness of sea ice, which forms quickly on the weekly basis, on the annual basis in the Weddell Sea.
So as you can see in this photo, guys, thank you very much to Sasha. I'm just gonna, I think while we've done Sasha's presentation, just gonna come out and see if anyone has any questions about Sasha's before we move on to Bettina. Let me just see how to navigate myself out of here. Hold on. So, all right, hello again. So thank you very much to Sasha for that. And let's see if there are any questions so far. Does anyone have any questions for Sasha about the ice in Antarctica and the work that he does using drones and radar?
All right, so if you...
How deep is the sea there?
Yeah, so one question that has come from Mr. Goran's class is, we'll have them come up to the screen and ask their question. When you ask questions, students, just make sure you use a loud, proud voice so we can hear you all the way down there. So we'll go Mr. Goran's first question, and then it looks like Miss Palmer's class will be the next question.
All right, you're gonna ask him right now.
How cold did it ever get there? In the Weddell Sea.
Could you repeat the question again? Sorry, we're having a little bit of lag on the internet here.
How cold did it ever get in the Weddell Sea?
Oh, how cold is it?
So far, I think it didn't get actually that cold. It was, I think, didn't get below -10 because it's still quite. It's not as high altitude. It's not as close to the South Pole. So it's not as, and also it's summer here, and also it's sea, which moderates the heat. So far, it's been quite relatively warm. It's been summer in Antarctica.
And maybe if you look on the comments, because we're talking about in degrees Celsius, but you guys talk in Fahrenheit, don't you? So we're -10 degrees Celsius.
Which would be about -20 Fahrenheit, I would reckon.
Yeah.
Yeah.
So it's very, very cold.
Yeah, but still not as cold as it can get during the winter. Yeah.
Yeah.
Excellent. We have next
question.
Very good question. We're going to go Miss Palmer's class, and then after that will be Miss Stevens' class, or Miss Davison's class. So Mr. Palmer, go ahead. Oop. Go ahead.
So I was wondering how the boat got its name.
How the boat got its name is a good question as well. So the Agulhas 2 is actually it's the second ship. There was one before called the Agulhas, and it's from South Africa. To be honest, I only know that this ship that we're on currently was named after the first one. So I would have to actually check out why the first one was called the Agulhas. All I know is, yeah, all that I know is that the one we're on currently is named after the first one. So let me get back to that, and I'll write that in my blog. That's a very good question. You make a note of that.
Great. And Miss Stevens' class, we'll have you next, and then we'll head over to Miss Kotzman's class. Remembering, we can think about what Sasha has told us about the ice as well. So here's Miss Stevens' class.
Any ice questions are great.
Can't hear you.
So Miss Stevens,
Can't quite hear you.
Yes, it seems like there's a little, we can't hear you. We can see your mouth moving, but we can't hear exactly what you're saying. So how about we'll go to Miss Davison for a real quick question for Miss Davison, and then we'll come right back to you, Miss Stevens, and you can also type it into the chat for us as well. Just double check your mic settings. All right, Miss Davison.
How do you take cool pictures in the water?
How do we get cool pictures in the water?
Well, I guess we use special underwater vehicles that have waterproof cameras in them. So they can dive deep in the water, and they can take not only pictures, but also videos. And actually for Bettina, they took lots of videos of life that inhabits the seafloor in this area.
Excellent. Excellent. And Miss Stevens, should we try one more time? And if not, I can relay your question. So the question is, if you have had any clues on finding the ship. And I believe they're referring to
Have we had any
Endurance.
finding the ship? That's also a very good question. So we have a brilliant team of archaeologists led by Menson Bound on board the expedition. And one of the jobs of the archaeologists is to spend time looking through the archives to understand where the most accurate last coordinates of where the Endurance is. So Menson Bound has spent a long time going through museums and historical records trying to uncover where the most likely location of the Endurance is. And that's the location that we are heading to. And actually the crew of the Endurance made very accurate readings of where the Endurance last was when it got trapped in the ice. And that's where we're heading 104 years later.
Excellent. And before we hear from our marine biologist, does anybody have any questions specific to Sasha's work, thinking about the ice, if there's different kinds of ice, how you get interested in working with ice? That's one thing I would love to know, is how did you become what you are today? But does anyone else out there, before he answers my question, have questions about ice in particular? It looks like with Miss Long's class, we haven't heard from you yet. I see some hands. So we'll do Miss Long's class, and then it looks like Mr. Whitney's class will be after that.
How thick is the ice?
That's an excellent question. It changes from glacier to glacier, from ice shelf to ice shelf, but where we have been, the ice thickness ranges between within the range of few hundred meters. So from 200 meters, 100 meters to all the way to 400, 500 meters. So it's half kilometer thick ice. If you think about it, it's 5 soccer pitches combined, stacked together in length. And then if you turn it around, there will be the thickness of sea that it reaches over this area in places.
Wow, that is very big. All right, Mr. Whitney's class, you're up next.
I was wondering why the ice is white there instead of clear.
Instead of clear?
Yeah.
It's a good question why ice is not completely transparent. And that's because you have many little scratches within the ice, actually. If you look at the surface of the ice, if you have a very thin smooth layer of the ice, which lacks any scratches, it will be transparent. But if you have thick layer of the ice where you have lots of scratches, it will reflect the light back, and so you won't see as much transmitted light that goes through and makes the ice transparent. So it's because of irregular surface and internal layers of the ice. But if this ice is perfectly lacks any scratches, and it can be transparent even if 500 meters thick, like a perfect glass, but it's never the case in reality. But also, if you look here, the ice is white just because it's covered by snow.
Excellent. Miss Kotzman's class, looks like you all have a question, so we will unmute you for a question. And then after that, I think Miss Latour's class has a question as well.
I was thinking, if there are different kinds of ice, yeah.
Are there different kinds of ice?
Oh yeah, another excellent question actually. There are. I would split the type of ice that we see here into 2 categories. One is the ice that is formed on land by precipitation of snow. The snow gets compacted, and this forms very thick pile of snow that then flows into the open waters. In Antarctica, this this glacier snow, the glacier ice can reach up to 4.5 kilometers in depth in the deep interior of Antarctica. And then these snow, this glacier ice is then calved in the form of iceberg, very thick icebergs, into the water, where it drifts away and then melts away and then contributes to the sea level rise. And then this glacier ice, this tip of very thick glacier ice that is formed inland, it forms over thousands, millions of years. Whereas there is another type of ice which is formed by the freezing of seawater in the ice, not on land, but in the ice itself. And that forms much quicker than that on time scales of days, weeks, and then it can stay for months and years. And this is the ice which we call sea ice, which is much thinner. It ranges from couple of meters up to 10 meters, but that would be anomalously thick sea ice. So say 3-5 meters. So this is the thickness of sea ice compared to really huge icebergs, which are nature of which belong to the inland.
Wonderful.
Excellent questions there.
Yeah. So next we're going to go to Miss Latour's class, I believe. Ready? Down there?
How fast how many feet does the ice glacier move every day? The one that's in the ocean.
Another excellent question. If you look at the map of Antarctica and color Antarctica according to the flow velocity of ice, you can see that it is drained by arteries of ice, by rivers of ice. So the flow, the velocity of the flow of Antarctica is not the same everywhere, but it ranges from very, very slow, like meters per 1,000 years per year, to kilometers per year. So the fastest ice in Antarctica, I believe, is about 5-7 kilometers per year. So if your school is somewhere on an ice stream on the very fast part of the ice flow in Antarctica, then in a year your school would have drifted like about 5 miles away. So very fast if you think about it, because if you just look at it, it seems to be so still and so stable, but actually it flows really quickly.
That's really fast. So maybe we can take 1 or 2 more questions about ice in particular, and then we can hear from our marine biologist next, because we also look like we have some questions coming in about the marine biology side as well. So Miss Paz's class, it looks like you all might have a question over here. So we'll head over to you.
How easy is it to break the ice?
How easy is it to break the ice?
It depends what sort of instrument you have. If you have a laser, it's very easy. You can do it from the distance. But if you have a nice axe, it's also quite easy. Especially if you warm it up.
Yeah.
Yeah.
So we're on an ice-breaking vessel, and this vessel is very, very impressive. It can break up to, well, I think we've broken 9 meters of ice, surface ice.
Well, it differs, but yeah, I think we broke quite thick ice.
Yes.
Up to above 5 meters, I think.
Yeah. So on the vessel itself, that we can break through up to 5 meters of ice, but we have other instruments that we use to, well, not really break the ice, but to core the ice.
Yeah, and we use samples, yeah. But if you're asking about the icebreaker, it's few meters. And the way it breaks the ice, it doesn't just cut through. It's shaped sort of like a ball, if you look at it at the cross section, and then this ball shape allows the icebreaker to actually lean on ice and put its weight on ice, and its weight that it breaks the ice. It's not that it cuts through. It's because it goes on top of the ice and then it breaks it by its weight.
Yeah, and it's very cool because we can be in our cabins. So a couple of nights ago, I was lying in my cabin reading my book, and suddenly I felt the ship lift up and go down and break the ice. And that is how we end up breaking the ice. Just as Sasha said, you go on top of it and you break it rather than going straight through it. So
Wow.
you can feel the lift.
That almost sounds like a fun experiment for you all to try. If there's any snow where you are, you could maybe build yourself an ice snowball and then try and put some weight on top of it and see if you can break the ice yourselves. So it looks like Miss Long's class has a question about the ice as well. And so we'll head over to them for a question. You're on.
The AUVs go through ice?
That's a good question. No, the AUVs don't go through ice. They go underneath the ice shelf, and they have an upward-looking motion multi-beam that can scan underneath the ice shelf, but the AUVs themselves don't actually break through the ice. Having said that, one of our AUVs did get stuck under the ice, so we had to use the Agulus 2 to break through the ice in order to free the AUV.
Excellent. And we'll take one more question. Miss Stevens' class's mic is not working right now, but their question is the ice thicker closer to the land or further out in the sea?
Another excellent question. Yeah, it is generally thicker if we take one ice stream or the drainage artery of ice sheet. It is actually thicker closer to the land, as I said before. In the interior, deep into the interior of Antarctica, it can reach up to 4.5 and more than that kilometers in thickness, whereas the marine margins of ice sheet in Antarctica can reach up to a few hundred meters in thick. So it's much thicker inland, and then it thins progressively. But there are variations, slight variations along the way, but generally it's much thicker in interior of the continent.
Excellent. Well, thank you so much, Sasha. And students, if you have more questions about the ice, please put them into the chat. And now I think we should turn to our marine biologist and then and see what her presentation is all about. And if questions pop up, please use the chat.
Yes, so I'm really excited to introduce you guys to Bettina from the University of Oxford and Necton. Bettina is our expert on board about what lives underneath the ice and in the Weddell Sea. That goes from marine animals to coral and sponges. So I'm going to introduce you to Bettina. Pass you over. Right. So Bettina, when you're ready.
Cool. Okay. Hi everyone. I'm gonna go into my presentation now. Ooh, no, I'm not.
Hold on, we're having a little technical difficulty.
There you go.
Yeah, there you go.
Cool. Hi everyone. I'm Bettina Frinault. I'm a marine biologist from the University of Oxford and Necton Foundation for Deep Sea Exploration. So I have two main focuses in my research. One being benthos, which is a collective term for any animals that live on or near the seafloor. And those include, for example, corals and sponges. And then my other interest is extreme marine environments. So those that are very deep or very cold, or both very deep and very cold. So those include hydrothermal vents, underwater mountains, also known as seamounts, and Antarctic seas, which, as you all can presume, are very, very cold. So when I'm referring to deep environments, I mean anything that's basically deeper than 660 feet. Yeah, so there you go. So that's what I'm interested in. Right, so I'm going to tell you what I'm doing here. So basically, I'm here to investigate what lives under the ice shelves on the seafloor in Antarctica, and also compare them to what lives on the seafloor in open water conditions where there's no overlying ice shelf. As you can see from my quick schematic, you might expect different conditions depending on whether you live under the ice shelf and in open water, because open water you have more sunlight penetration, more wind-driven currents, and that all influences all the underlying layers of water column. So you might expect, for example, more marine snow to be falling down into, through the water column in open water conditions than ice shelf, because ice shelf acts as a barrier. So basically my questions are, what on earth lives here, because no one knows, and why do they live here? What determines why they live here? And I just wanted to point out how very, very dark it is at the depths that we're looking at. At the moment, I've been looking at places which are 400 meters deep, and so basically they are like this, absolutely pitch black. You can't see a thing, but we have lights. Ta-da! So that's what you see when you illuminate the seafloor in Antarctica. A lot of animals. So how am I going to collect the data to find kind of like what is living on the seafloor? So new technological advancements in underwater robots. So we're using 2 different kinds of underwater robots. We're using a remotely operated vehicle, which has basically a line which is attached to the ship, and our ROV is named Lassie. And then an autonomous underwater vehicle nicknamed Chippy, which basically operates without having a line to the ship. So we put in some waypoints, and then it just follows along those waypoints and takes images of the seabed. So both underwater robots have HD video or stills camera and really powerful lights, important to illuminate that seabed, remember. And even Lassie, our remotely operated vehicle, has a claw and a box in order to collect animals from the deep. We bring them up to the surface, and then we'll process these animals and investigate, how their internal structure is formed, and then also we'll do genetics. So we'll figure out how closely related different species are. So that's what we're going to be bringing up. So I thought I'd show you what we found so far using these underwater robots. So these are new images. No one's ever seen these before. And this is what we found so far in the Antarctic. Ta-da! So on the top, you've got what are commonly known as sea pigs. Really, really cute critters. They have basically a ring of tentacles from which they use to deposit feed from the bottom of the sea. So they'll feed on mud, deposits, and just extract from that. And then below you have a feather star, which is a filter feeder. So all of those kind of like feather-like plumage, that's kind of trapping marine snow, and then it comes back into its mouth and just feeds. So it's like this. You've got sea stars, and that's a basket star. So that's again a filter feeder. It's got hairy legs. So to have any of the marine snow attached to it, and then again it feeds into its central mouth disc. So it's like this.
They can't see you.
Oh, they can't see it. Okay. Whoops.
You can see the slide thing.
Okay. More stuff that's been found. So we've got some beautiful sea anemones, corals, sponges, and lots of fish. And some of these fish, also known as ice fish, have this really cool antifreeze blood that basically prevents them from being fish popsicles and freezing up. So they're very, very cool species. We also found an octopus. So quite a surprise. We didn't not expect them to be there, but we didn't expect to see them because we thought that maybe the remotely operated vehicle would have scared them off. So that's an octopus on the screen. It's right at the back, so you can see it's trying to hide. And then in front of it, I don't know if you can see it, there's a rock which has a brittle star, which is kind of like a pinky, bright pink. So another little critter there for you. So basically we're seeing lots and lots of new species which haven't been encountered before. So there's the octopus hanging out over there. He scarpered off pretty quick as soon as we came closer, so we didn't get a better image, unfortunately. Those are the species we've seen, and I'm really happy to share more images of what else we've seen, because that's not it. There's plenty more. If you've got any more questions, please put them through. And if you've got any questions that you want to ask me on email, my email's down there. So yeah, feel free. And in the middle of the screen, that's Lassie, just before she's about to go on operation.
That's the underwater robot. Right, let's get you back on. There we go. Awesome, that was so cool. How amazing how much lives underneath the waters in Antarctica. And thank you so much, Bettina, for sharing that with us. So maybe we could open up. Does anyone have any questions for Bettina? And loads down the side.
Yes, it looks like we have lots of questions. So we'll go right in a row. We'll start with Miss Ives, and then we'll go to Miss Long, and then Miss Kotzman. So that'll be the first 3. So let's start with Miss Ives. Here you go. And then Mr. Whitney, I see you waving too.
I have a question. What are you able to tell from the temperature of the water? What does this show about the aquatic ecosystems?
So a lot of the animal communities, they're dependent on the environmental factors. So temperatures are very, very important determinant of what can exist there. So you wouldn't expect, for example, any tropical species to be in the Antarctic, of course, because it's too cold for them. But in general, at the bottom of the seabed in the Weddell Sea, the temperature is relatively the same. So it's about -2. So you're not going to kind of get too much deviation in the temperature down that depth. But yeah, temperature, very important environmental determinant in terms of what you're going to see. So good question.
Great. And Miss Long, you guys are up next.
What's your hypothesis for what you're going to find?
Oh, good question. Okay, so I'm going to be looking at basically a difference between animals that live under the ice shelf and animals that don't live under the ice shelf. So basically, I'm expecting that there will be more predators and more deposit feeders, those that feed on sediment, under ice shelf, because they haven't got access to the marine snow that normally exists when there's an open ocean. So basically, you have in open ocean, you might have a phytoplankton bloom, and then from that bloom you get deposits which fall through the water column, and then they go down and they settle on the sea floor. You haven't got that when you've got a barrier such as an ice shelf. So my hypothesis is I'm expecting different critters depending on if they live in open water conditions versus under ice shelf conditions. So we might expect, for example, in open water conditions, more filter feeders which are able to extract kind of like deposits from in water and put them in their mouth. So that's kind of like the difference we're expecting. Predators and deposit feeders versus filter feeders.
Very good question.
Very good question. That's interesting to think about the difference between what kind of feeders they might be. Next, we have Miss Kotzman's class.
What do you do with the animals you collect?
Okay. So we take really, really good photographs of them and really good close-ups so that we have them to put in an identification book, and then we'll run genetic analysis on them to find out how closely related they are to each other. So we want to see if they're the same species or if they're completely different, and we want to see if they're new species, and we're not able to fully determine if they're new species without having the genetics first. So we need to test the DNA which determines what species they are first before we can determine, hey, this is definitely a new species, so we can name it.
Do you already have names in mind if you find some new species?
Holly.
The holly. We have some names in mind. They tend to be kind of more affiliated to how the animal looks. So we have I'm not going to remember the Latin name, but we basically have a name in mind for a coral which looks like a foxtail. So we've got the Latin name for foxtail to call that coral if we do find that it's a different species. So yes, we do have some names in mind. Often also the species are named after the last name of whoever found it. So so we're going to see. We'll probably have to fight over it. There's 2 other marine biologists on the expedition.
It's very exciting. So, Mr. Whitney, it looked like you all had a question. So we'll go to Mr. Whitney's class, and then it looks like Ms. Long's class has another question as well. So we'll head over to Mr. Whitney's.
What types of bacteria are in like the water and the ice?
Oh, you're the ice expert, so you can do the ice. So I'm definitely not kind of like a microbial level marine biologist. That's definitely expertise in a different kind of realm for me. But we have seen some bacterial mats which are super interesting. So another kind of I don't know, nugget I can give you is that we found something quite unexpected called a cold seep. And basically these cold seeps, they're evidenced if there's bacterial mats on them and if there's any bivalves. So basically, all I can tell you is that we've seen some bacterial mats, which is super cool because it means that there's something underlying there for them to be there in that quantity. So yeah, I can't tell you too much about bacteria, but under the ice shelf, what looks like bacteria sometimes is ice algae. So it gives it kind of that brown look, brown coloration. So you might have like diatoms there, which are all kind of like, so they take their energy from sunlight. So sometimes when you see a dirty piece of ice, it's not dirty, it's actually got animals on it, living in it.
Yeah, this algae is actually quite important for the ice melting because it has it's darker than the surface of the ice and the snow, and so it doesn't reflect as much sunlight because of its color, and therefore it gets warmer quicker. And because it gets warmer quicker, it warms the ice that surrounds it, and so the ice and snow that is covered with algae tends to get warmer and melts quicker.
Interesting, and I believe Holly has sent through a picture for us of those diatoms so we can share underneath the microscope. Like Ms. Long, did you have a question for your class as well? I see some hands, so we'll unmute you and you can go ahead and ask your question.
Do the AUVs go down to the bottom, and how long does it take them if they do go down?
So we have two different types of autonomous underwater vehicles on board the expedition currently. One goes close underneath the ice shelf, about 50 or 70 meters underneath the ice shelf, and it looks up, scanning underneath the ice shelf. The second AUV that we have is a sub-bottom profiler, which goes on by the seabed, and it scans downwards using a multi-beam and side-scan sonar. And that scans from about 50 meters above the seabed. So we have two different types of AUVs, one that's under the ice and one that's on the seafloor. The one on the seafloor, the one for underneath the ice, we're using primarily for science. And the one that's on the seabed we're using for science, but that will also be the AUV that we'll be using to try and find the wreck. So we'll do another call about the wreck itself, but what happens is the AUV gathers data from the seabed and it scans the seabed to see if there are any anomalies. Then the data surveyors will spend hours going through this data and try and see if there's anything that looks unusual on the seabed that might be man-made, which might be a wreck. If they do think that we've located a wreck, then we will send in the ROV, which is another underwater robot, the one that Bettina showed you in the photograph, to go down with a camera and survey the area. And the missions that we have with the AUVs can be 10 hours or 60 hours. On this expedition, we're doing about 12 to 10 hour missions. But on other expeditions, on other trips that we do, which we use Ocean Infinity's autonomous underwater vehicles for, they can run for up to 60 hours. They can run simultaneously. So you can have up to 5 to 6 AUVs in the water all at one time, running lines and scanning the seabed. So you can cover a lot of the seabed area if you're looking for a shipwreck.
That's cool.
That's very cool. So we have a question that has actually come in from Russia as well. Two parts to it, possibly one for each of you. So what dangers await sea creatures in the Weddell Sea? And then the second piece is, what does the melting or how does the melting of ice endanger krill?
Okay.
I can answer the first, well, partly at least, I answer the first one. The calving of icebergs, when icebergs are quite thick, and because the seafloor is not of uniform depth, it can have shallow banks, which is inhabited in turn by many marine species, as Bettina showed you. And so when icebergs reach the surface of the shallow banks, get in contact with it, because there's such a huge masses of ice, they of course will destroy any of the creatures that gets in contact with such a big mass. And in fact, if you look at the morphology of the seafloor in both Arctic and Antarctica, they're often in shallow depth, about below 200, above 200, 300 meters, are plowed very heavily by icebergs. So this is a potential danger for them from the icebergs.
So not only that you might get disturbance from iceberg scour, you might also, those communities that I spoke about which live under ice shelves, obviously with ice shelf disintegration, they're going to have a very big difference in terms of their conditions. If that ice shelf moves off from them, they're going to be exposed to lights and marine snow, which they haven't been exposed to before. So it might be that there's greater sedimentation rates, so they get smothered. So that's an additional thing which might happen with ice shelf disintegration. There's also, we've got to consider global warming with respect to oceans warming as well. A lot of these species are very happy in the current conditions. So, you know, over the next 50 to 100 years, if it does indeed get warmer, those oceanic temperatures, they may suffer as a result. So yeah, we'll be doing lots of basically predictive modeling to find out what climate change impacts are gonna arise on these communities.
Excellent, thank you. And I see we have Miss Long's class has another question or two. And I also just wanted to let you three know that on the East Coast in the United States, it's about 3 o'clock in the afternoon. So as you've seen some classes leave, that's because they're getting ready for their end of their day. And we might still have Mr. Rogers' class with us, and we definitely still have Miss Long. So we'll see if they have a few more questions for us, and then we can wrap up for the day. So back to you all over at Miss Long's class. Let me just unmute you. All right, go ahead, Miss Long's class.
How fast can the boat go? The big ship.
That's a good question. So the Agulhas 2 is a very sophisticated vessel, and we've actually been up to about 14 knots. We usually travel at an average at about 8 to 10 knots when we're in open water. But when we were leaving Penguin Bukta on our way to the Larsen Sea ice shelf, we were trying to make up days that we'd lost due to delays because of weather. The flights couldn't go. So we actually traveled at an immense speed of 14 to 15 knots. When we're traveling through the ice, that's obviously a lot slower because we are breaking ice. So we can't charge through. And as we explained earlier, you have to go on top of the ice and break it. So that can be as slow as 2 to 3 knots. But on average, if we're in open water with no ice around us, we will be traveling at about 8 to 10 knots.
Should be about 15 miles per hour?
Yeah, 15 miles per hour, yeah. 16 miles per hour. Yeah.
What type of allergies are down there that you've discovered, and how can they impact the animals that live down there?
What was
type
the
of
question?
allergy?
Allergies? Allergies, let me think. Oh, actually, we haven't really seen any allergies yet, because all we've done is we've taken photographs, so we haven't done any of the work yet when we've been looking at the specimens that we've collected yet. So I'm not quite sure what allergies they've encountered just yet, but I'll look out for them and let you know.
Thank you. Thank you. Thank you. Yay.
I've just seen two really good questions from Mr. Whitney's class, who I'm assuming had to leave, which I thought we could, they tune in most weeks. So we just asked the questions from Mr. Whitney's class as well. What do the sea pigs eat?
So sea pigs are deposit feeders. So they basically eat sediment and extract kind of all the goodness from the sediment and then eject.
And Bettina, what do you mean by sediment?
Oh, so sediment, so all the muddy kind of sandy stuff on the sea floor. So they'll use their tentacles around their mouth. So they have like a circular array of tentacles around their mouth. They'll bring in all of this deposit and then just like mush it around and then eject anything they don't want. So they take all the good nutrients and then get rid of the rest. And often they're quite, sea pigs are transparent, so you can sometimes see the sediment like in all of their intestines. So it's kind of gross but fascinating at the same time.
And then another question from Mr. Whitney's class was, what is the average wind speed and highest wind speed both you are experiencing and on record? Gosh, I don't know what the highest wind speed is on record, but I can tell you that I've got the weather report here. We have a meteorologist on board the expedition from the South African Weather Service called Tappy, and she's written an awesome blog on meteorology on the Weddell Sea expedition website that's worth checking out. But the wind speed is up to about 10 knots this week. So quite strong. We've had, you can really feel it when you stand outside. This morning when I went out on the back deck, the back deck was clear. There was no snow on the ground. I went back 3 hours later and there was a lot more snow on the ground and a lot stronger wind. I came in with my hair all over the place. So just to give you an idea that the wind can change very, very dramatically in a short space of time when you're in Antarctica.
Excellent. So Miss Long, in your class, if you guys have one more question for us, we can probably do one more question for the team here, and then any other questions we can continue on our next video conference. Do you have any other things you're wondering about the sea ice, the marine life?
So yeah, we have one more question. She's just coming up to the front.
Great.
What is your guys' favorite food so far on the expedition?
Good question. This is, we are all obsessed with food on the expedition. And if you saw the last vlog, the last call that we did, we were with two of the chief steward and the purser on board who spoke a lot about the food that we get on the ship. We actually have to have enough food to last from the 6th of December until March 11th. So a very, very long time. Maybe we could all just go around and say what our favorite thing that is supplied is. Bettina.
So far, the Mississippi mud pie.
Yeah, the Mississippi mud pie is good. Very much so.
Good question. I love ice cream.
Yeah.
And it's really
Every Saturday we get steak followed by ice cream with chocolate sauce.
Yeah.
It's great. Definitely. And then my favorite meal is probably the cheesecake. I like the cheesecake. But also, I have to say, what is really nice on the ship is that we get fresh fruit still. And really fresh fruit and fresh vegetables are craved when you're offshore. You know, we don't have the luxury of going home and having our parents cook a nice home meal with lots of vegetables. We get oranges and apples and sometimes plums if we're very lucky, if they're feeling generous. So I actually really love getting fruit and vegetable when we're offshore, when we're on the expedition. So make the most of your fruit and veggies.
Absolutely.
Excellent. Well, thank you so much to you, Holly, and to Sasha and Bettina for joining us today. This was very exciting. We've seen the first images coming out of Antarctica with some of the marine life that is down there, and also have been able to visualize how thick and how wide and vast some of the ice is as well, which is absolutely amazing. So thank you both so much for joining us today. And thank you to our classrooms. Many of them have popped off already, but we'll unmute everyone at once so that everyone else can say, who's still here, say goodbye, and thank you to you all as well. So let me just unmute. All right. There we are.
Bye-bye.
Bye. Thank you.
Bon voyage.
Thank you, everyone.
Yes, and we'll be back again soon with Holly next week and some of her next guests. Stay tuned to our newsletter to see who they are. And Holly maybe wants to show us out her window, perhaps. Is that what you're looking at? Excellent, I thought so.
Yes.
Go right ahead,
Our
Holly.
window, we've got a really, there's an iceberg outside our window that we're going to show you. And the bird. So I'm just climbing up onto my bed. Hold on. I don't know if you can see. It's quite foggy outside. Can you see that bit of ice? It looks quite small from the camera, but it's quite a large piece of ice. So very cool. Awesome.
Excellent. Well, thank you all so much, and thank you for tuning in today for our video conference. And we will see you on Monday, Holly, for our next live stream video conference from the Weddell Sea. So thank you so much to everyone.
And I think that joining us next week, we will have Bettina's supervisor, Lucy Weddell, and Sasha's supervisor, the Chief of Science, Julian Dowsdall, to reflect on the science that we have achieved during the Weddell Sea expedition. So yeah, tune in for more.
Excellent. Well, thank you all and have a wonderful evening or afternoon.
Thank you.
Thank you.
Bye.
Bye-bye.